In this LP360 tips and tricks video, we're going to show you how to grid your LAS point cloud data. Why would you want to grid your data? Well, there are several reasons when you might find it useful to have a gridded data set. It may be required for downstream workflow or a particular software tool. For instance, AI ground classification often requires an orthogonal grid of data. You may simply want to reduce the individual file size. You may be dealing with a single large flight or drive and have a single large LAS file. You want to divide that up to make it a little bit easier to work with. In a nod to more traditional LiDAR production environments, you may want to divide the work across a production team. You may have a large enough project that you're going to have several technicians working on feature extraction or classification, and tiling your data is a good way to organize and manage that team's work. Or you may simply want to improve the viewing and editing performance of your data set. So the solution here is to use the grid generator point cloud task in LP360 to create a tiled LAS layer in your project. Okay, so here we are in LP360. I've got a TrueView drone LiDAR data set, but the concepts I'm going to show you here apply to almost any point cloud data set. And we want to create a tiling scheme and grid our data to that tiling scheme. I'm going to create the tiling scheme within LP360 using our gridding tool. But if you have an existing tiling scheme that perhaps your client has given you or that you've used previously on the same job site, you can always just import that as a feature file, so as a shape or a CAD file, and use that. But let's say you don't have that, you just want to go ahead and do a grid of your data. So if we go to the point cloud tasks, this is the task that you want to look for, called grid generator. It's in the library by default, and it's a relatively straightforward task. We're going to feed it in a particular LAS layer, and we're going to give it a cell size. For drone data, we found 300 meters, 1,000 foot is generally a decent place to start. You can, of course, tweak your tile sizes for your particular application or your particular use case. But if you're just looking for a general default, 300 meters seems to work very well for most drone LiDAR data. We're going to grid that data. We're going to do a full grid. That is, we are not going to clip the grid to an existing boundary. If I had a job site boundary or a project boundary already in my map, I could just clip my tiles to that boundary. That can be useful as well. In this case, we're just going to grid the entire LAS layer, and we are going to clip it to the input LAS data. I do need to give it an output path. We're going to be basically creating a shapefile with our tiles in it. So I can use my IO manager to specify a path. I can use my project path variable, and I have a set of folders. I'm just doing my grids. This is a 300-meter grid. And I'm going to add the grid file into my map. So I'll go ahead and run that now. It's a point cloud task. So we just run it from the point task ribbon, and we're just going to run it on the active layer. I'm just working on a LP LAS layer I have in my map here. So there we go. It took about 45 seconds on this data set. And I'll just fit my map. And so you can see that it has created my tiles, an orthogonal set of tiles, and it has set it to cover the entire LAS layer. Now, typically you're going to collect a little bit beyond your boundaries, a little bit beyond your area of interest for your job site. So often you'll get some of these edge tiles which really aren't required for your project. And so you can just quickly edit those out if you don't want to use them. I'm going to go to my feature edit ribbon up here, and I'm going to go in and select this tile here. Doesn't look like it's too critical for me. The one on the east side is not critical, and this one down here has no data in it. So I'll go ahead and I'll delete those tiles, and I'll go ahead and save that. So now I've got 6 tiles that cover my LAS data. I now want to go ahead and grid that LAS layer into this tiling scheme, and I do that using Export Wizard. So I'll go back to my project ribbon. I'll go to my export wizard. I'm going to export my points. No, you could apply a filter at this point. And if you, for instance, had just done geocoding and maybe done outlier detection or done some manual cleanup of your noise points, and you just simply wanted to remove those from your point cloud, you could apply a point filter here and just exclude those. It is one way to clean up your point cloud as you're going through your workflow. I'll just leave it as is. I'm going to go ahead. And here I want to specify cookie cut by polygon. So this is where we're going to create the individual LAS files for each tile. So when I say we want to grid the data, we're taking our single LAS file that covers our entire job site, and we're creating a set of LAS files with one LAS file for each tile. So that's the cookie cut by polygons approach. I have the polygon layer that I created, grid 300 meters. There are 6 polygons in it. I could just select certain ones and just run against those, but generally you will typically run against your whole gridded layer if you've cleaned it up, as I did. We'll just use the ID as the name field, give it an output location to store the data in. In this particular case, I'm going to put it in outputs, and I'll create a new folder here. We'll be very specific about this. This is a 300-meter grid. And I do want to insert my exported LAS back into my map. I'll go ahead and run that. So now I've got my new gridded LAS layer. Make sure that is set as my active LAS layer. And if I go to my map ribbon, I do have a set of tools here. You may not have used these if you've only worked with single LAS files or small LAS projects, but I can actually turn on those boundary displays in the map view. So now I can see the specific sets of tiles that I have on this particular layer. For drone data, as I mentioned, 300 meters, 1,000 foot, that's a good place to start. You can tweak and adjust that for your own particular use cases. As I mentioned, if you have an existing tiling scheme, maybe 300 meters isn't really what you want, or you have an existing tiling scheme from your client or your customer, you can always import that as a feature file, as a shape or CAD file, and use that for cookie cutting your data. Just to show you, I have an example here of an earlier data set where I used a 100-meter grid, an existing 100-meter grid that I had brought in as a feature file, and the corresponding LAS layer. One advantage of working with tile data in LP360 is you can control the individual display of the individual files graphically right in your map view. So for instance, if I turn off my feature layer, my grid, turn on my display by boundaries so I can see my boundaries, I can use this option here, select and load graphically. It's a very useful option. If I have this on, then by selecting tiles graphically in the map, I can load in the individual tiles for review or editing or viewing. I can do multiple tiles. They don't have to be contiguous. If you use the standard Windows control keys, I can load non-contiguous tiles. So there can be different use cases or different sort of editing times or viewing times when you may want to load different sets of tiles to look at them for editing purposes or so forth. I can, of course, load the whole data set still if I want to. And I can unload it as well. So having this tile data set gives you flexibility and a way to organize your job and organize your tasks in a structured way. And as mentioned, you may have downstream workflows or downstream tools such as AI ground classification where you're required to have this sort of orthogonal tiling working for you. So, in summary, if you need tiled LAS data, you can use the LP360 point cloud task grid generator to generate a grid of any size and an orthogonal grid of any size, and use that to export to cookie cut your LAS data into your tiled scheme.